This is how to write a net ionic equation. First step in writing a net ionic equation is to write a balanced double replacement reaction and identifying the precipitate. So we're going to write phase notations. Aqueous is a phase notation. S for solid is a phase notation. So for the double replacement, it's first and last. This is chromium with a +2 charge. And then last is sulfide plus third and second. Do not carry over this 2 or this 2. So it's going to be lithium and then nitrate, which is everything in the parentheses. Now we have to balance the charges. The chromium has a +2 charge, the sulfide has a -2, so those cancel. The lithium has a +1, the nitrate has a -1, and then those will cancel. Now that we have our products, we can determine which one is our precipitate. The precipitate is going to be insoluble. So I'm going to look here at sulfide, and on my solubility rules, here's sulfide, and chromium is not one of the exceptions, and therefore, because that's insoluble, chromium sulfide is my precipitate. So I will label that with an S for solid to denote that that is our precipitate. And then that means that this one automatically is aqueous, although we can verify it. Here is the nitrate ion. It is soluble with no exceptions. So because this is soluble, it gets an AQ for aqueous. To summarize that, because this was insoluble, we labeled it a solid because that is our precipitate. Because this one was soluble, we labeled it AQ, which stands for aqueous or dissolved in a solution. I'm going to write what's called the ionic equation, which is all the aqueous solutions dissociated or separated into their ions. So I'm going to be separating this, and this one, and not separating my precipitate to make my ionic equation. Before I proceed, I am going to need a 2 coefficient here in order to balance out the 2 lithiums and the 2 nitrates on both sides of the equation. We have 1 chromium, 1 sulfur. So now we're going to write the ionic equation. I'm going to break this into its 2 ions, the chromium +2 ion, so that's going to go Cr +2, and then I'm going to put AQ for aqueous, plus the nitrate ion. I'm going to write NO3. Since there's 2 of them, I'm going to give it a coefficient of 2 nitrates, and it has a charge of -1, and then we'll put AQ for aqueous. So this has now been broken apart into its individual ions. Then I'm going to put a plus, and then because this is aqueous, we'll break it apart. There are 2 lithiums, and the charge on lithium is a +1, and we'll put AQ for aqueous, plus 1 sulfide, which has a -2 charge, and we'll put AQ for aqueous, and now I'll draw my arrow. So I broke down both of my aqueous solutions into their ions. On the right side of the arrow, do not break down the precipitate, CRS, solid, plus, and then I will break down this one because it's soluble, and there's a 2 coefficient in front, which means I have 2 lithiums and 2 nitrates. So it's going to be 2 lithiums with a +1 charge, aqueous, and 2 nitrates with a -1 charge, also aqueous. And this is my ionic equation. Now in your ionic equation you have everything that was aqueous broken apart, but not the precipitate. Because it's insoluble, it does not break apart. So the spectator ions are the ions that don't undergo a chemical change and are not part of the precipitate. So we're going to identify our spectator ions. Nitrate here is my first spectator ion, and the lithiums are my second spectator ions. These are the ions not involved in the precipitate, and they appear identical on both sides of the equation. We're going to cross out the spectator ions because we usually don't include them in the last part, which is the net ionic equation. Now that we have identified lithium and nitrate as the spectator ions, we can write the net ionic equation, which is going to represent the chemical change of the precipitate. There should be no spectator ions present. The final answer is going to be the chromium +2 aqueous ion, not the spectators, plus the sulfide -2 aqueous ion, yields the precipitate CRS solid and then not these spectator ions. This is considered the net ionic equation and your final answer.